Hello students, in this session let us learn to find out the eigenvectors of the corresponding eigenvectors of eigenvalues of linear transformation. In this problem it is given that T is a linear transformation from V2 of R to V2 of R defined by T of E1 equals to 1 comma 2, T of E2 is a vector, it is 2 comma minus 2. Find all the eigenvalues and the corresponding eigenvectors. Let us take the given thing, that is T of E1 is 1 comma 2, T of E2 is 2 comma minus 2. Write these two vectors in column vector as it gives matrix of linear transformation 1 2 in the first column, T of E1 that is 1 comma 2, write it in first column in the matrix, and T of E2 2 comma minus 2, write it in second column of the matrix. Then the corresponding characteristic equation of the given linear transformation is determinant of A minus lambda equals to 0. Write the given matrix in the characteristic equation form, that is determinant of 1 minus lambda, 2 and minus 2 minus lambda equals to 0. Expand this determinant, you get one quadratic equation in lambda, 1 minus lambda into minus 2 minus lambda minus 4, multiply each term, then simplify this, then you get lambda square plus 3 lambda minus 2 lambda minus 6 equals to 0. So that you get two factors, lambda minus 2, lambda plus 3. Lambda minus 2 and lambda plus 3 are the two factors of this quadratic equation. From this we can find out the values of lambda as 2 and minus 3. 2 and minus 3 are the eigenvalues. The roots of the characteristic equation, are said to be eigenvalues. So, if we solve the quadratic equation, what we got from the characteristic equation expansion, then those two are the eigenvalues of the given. To find the eigenvector corresponding to each eigenvalue, in this problem we have two eigenvalues, lambda equals to minus 3 and lambda equals to 2. So, with respect to minus 3, let us consider capital X, it is in the form column vector x comma x and y, column matrix, that is x y, take it in column matrix, column 1 cross 2, like that column matrix. Let us consider capital X equals to x y in the form of column matrix, be the eigenvector corresponding to the first eigenvalue lambda equals to minus 3. Write it in the form A minus lambda I into x, A minus lambda I into x matrix form. So, here the lambda is minus 3, here the lambda is minus 3. So, it becomes A plus 3I into x equals to 0. So, add 3 into I, that means 3I matrix to the matrix A. A is the given matrix of linear transformation, that matrix is added with 3 to the diagonal elements of A, you get 4 2 in the first row, 2 1 in the second row, multiplied by the column matrix xy, multiplied by the column matrix xy equals to 0 matrix 0 0. Then you simplify this given matrix, by to the row reduced echelon form, so that you can apply the row operation. R1 is divided by 2, you get 2 1, R1 is divided by 2, you get R2 comma 1, 2 and 1. R1 is divided by, first row is divided by 2, we get 2 1. So, since two rows are same, we can apply the row operation as R2 minus R1 to get 0 row in the second row. Okay. So, then R2 minus R1 you get 0 row in the second row. Then you can get one simplified equation from the above matrix, 2 into x plus y, 2 into x plus y equals to 0. From this we can find out the values of x and y by assigning one of the variable x or y as t. We can take either x as t or y as t. Okay. Here we took x equals to t. Put x equals to t, you get what is the value of y. If we substitute the value of x as t, you get the value of y as minus 2t, minus 2t. So, the column matrix capital X gives the eigenvector corresponding to the eigenvalue lambda equals to minus 3. So, write x value in the first place, that is t, and y value minus 2t in the y place. So, this gives the eigenvector column vector in the column matrix t minus 2t is the corresponding eigenvector with respect to eigenvalue lambda equals to minus 3. Okay. In the same way, we can find out another eigenvector corresponding to the eigenvalue lambda equals to 2, which is other eigenvalue lambda equals to 2. Let us take x y in the column matrix form as eigenvector. Then replace lambda by 2, in this equation, lambda minus a minus lambda I into x equals to 0, replace lambda by 2, a minus lambda I equals to 0. Then you get the matrix a minus 2i, given matrix is a. Subtract the diagonal elements with 2, subtract the diagonal elements, principal diagonal elements with 2, you get minus 1, 2 in the first row, 2 minus 4 in the second row. Remaining terms are like this. Divide R2 by 2, you get 1 minus 2. Then add these two, first row, second row is added with first row, you get 0 0 in the second row. So, that the equation obtained is minus 1 into x minus x plus 2 into y, 2y plus 2y equals to 0, minus x plus 2y equals to 0. Okay. Then substitute the value of x or y as k or something like t, any variable you can take. So, put y equals to k, we get x value as 2k. Okay, substitute for y as k and simplify this equation, you get the value of x as 2k. Then write the values of x and y here, that is capital X equals to 2k and k in the first column, in the column matrix. Okay, is the eigenvector corresponding to the eigenvalue lambda equals to 2. So, these two eigenvectors forms one matrix P, diagonalizing matrix P. So, once we get eigenvectors, the given matrix is said to be diagonalizable. So, diagonalizing matrix can be formed by writing the first eigenvector in the first column and the second eigenvector in the second column as like this. What is the inverse of P is adjoint P divided by determinant P, right? Adjoint P divided by determinant P. So, determinant of P means what? Multiplication of principal diagonal elements minus the other diagonal element product of diagonal elements, principal diagonal elements minus product of other diagonal elements. So, 1 minus of minus 4, it becomes plus 4. So, 1 plus 4 is 5. So, this is determinant of P is 5. So, 1 divided by determinant P is nothing but multiplied by 1 by determinant P, right. So, 1 by 5 we write. Then what is the adjoint of this 2 cross 2 matrix? We know that interchange the principal diagonal elements and change the sign of other diagonal elements. So, write the 1 1 in the principal diagonal elements as it is, and that means no change if we interchange both these two principal diagonal elements. Then change the sign of other diagonal, that means plus 2 becomes minus 2 and minus 2 becomes plus 2. Okay, this is our adjoint of the matrix P. So P inverse is nothing but adjoint P multiplied by 1 by determinant P. So this gives the P inverse of the matrix P. So what is the diagonal form is nothing but P inverse AP equals to D. P inverse AP gives diagonal matrix P inverse A into P. Write the P inverse matrix, substitute for the given matrix A, and write the matrix of eigenvectors, which is the matrix P. Substitute all this and simplify. Write 1 by 5 as it is, then multiply these first two matrix, multiply these first two matrix, then keep the third matrix as it is, then simplify the first two matrix, then multiply with the third matrix, and again simplify. You get minus 15, 0, 0 and 10. Then you can take 5 outside, then you get 5 cancelled with the determinant P value 5. Then the remaining terms are minus 3, 0, 0 and 2, which is in diagonal matrix, which you got in diagonal matrix form. That means only diagonal elements exist, other elements are zeros. So P inverse AP equals to D. If they ask for diagonalize the matrix, then you write these steps, or you no need to write the diagonalization of the matrix. If they ask in the question, you can write this, or else if they ask only eigenvalue and eigenvector, you can stop here itself. Okay, thank you. And try these type of problems which I have given in the last slide. Okay, thank you.